SL 4.12 Standardization. In today's video, we will be discussing standard normal distribution. So in previous section, we have already discussed that when we have normally distributed presentation or the graph, its graph will always look like a bell shaped like this, okay? And its center is always the mean value, and we describe the distribution of the variables or the data using the standard deviation. So one standard deviation away, two standard deviation away, or three standard deviation away, or the same thing on the left hand side like this, right? So if you look at this diagram here, this diagram below here shows how the z-scores are related to the general normal curve. So when we have a mean value in the center, its z-score is always 0. And when we are one standard deviation away from the mean, its z-score is 1. If we are two standard deviation away from the mean, we have a 2 as z-score. Or if we are 3 standard deviation away, we have a 3 as a z-score. And same thing on the left hand side. Okay, so when you look at this diagram here, notice that the value of the z-score corresponds to the coefficient of the standard deviation in the x value in this diagram, right? So in that case, we can say that the z-score of the x is the number of the standard deviations x is from the mean. And also we can say that when we have a positive z-score value, x is 1.84 standard deviation to the right of the mean. Or if the z-score is negative value like here, negative 0.273, then that is 0.273 standard deviation to the left of the mean. That's how we can say about it. And also, because of this, we have to say that z-scores were normally distributed. Z-scores are normally distributed with mean value equals 0 and standard deviation value equals to 1. So this is something that you need to remember. And as you can see here in the formula box, we have the z is n bracket 0, 1 square is called standard normal distribution or the z distribution, right? This is the notation that identifies the z distribution. And also, another thing that you need to remember is that each value of the x, we can calculate the z-score using the algebraic transformation. Means we can use the z-score to find the unknown mean or the standard deviation value. Okay, then let's try questions such as example number 1. Okay, then let's try example number 1 together. So we need to find the mean weight of the group of people that have a standard deviation of the 7 and 32% of their weight less than 68 kilogram. And the question tells you that this is normally distributed data. So how do we know it's normally distributed? Because we are just talking about the weight, which is the one variable data. So it's one variable. And because of this, we know that this is normal distribution. Okay, so let's first draw a normal distribution graph for this data. Okay, so we know that probability of x value less than 68 is about 0.32 or the 32%, right? So when we draw normal distribution graph with this, we are not sure about the center, the mean value. However, at the point of the 68, anything less than the point of 68 is considered as the 32% or the 0.32, right? So, and also we are aware that standard deviation value is 7. So since we are trying to calculate the mean value, we have to standardize this information. Okay, so standardized means that we're going to push the mean to 0. Okay, so when we have standardized the graph, our mean value becomes 0, and then instead of 68, we use the z. We try to calculate the z value. and the area below the Z value is still 0.32. Okay, and then in this case your standard deviation now becomes 1. So we first have to use inverse norm to calculate your Z score. Okay, so with the inverse norm function in your GDC, we have to use the area equals 0.32. Your mean will be 0, your standard deviation is 1. Okay, then your score is, that score is negative 0.4277. Once you have this value, you're going to use your algebraic expression z equals x minus mean divided by standard deviation. So we know that z is negative 0.4277 and x from the question is 68. Mean is the value that we are not sure, but we know the standard deviation as 7. And using this, once you have this equation, you solve for the mean value. So we're going to rearrange this into negative 0.4277 times 7 minus 68 equals minus mean. Then mean value is equals to 71.3 kilogram. Okay, then now let's talk about Z scores and then the algebraic formula one more time. So if you are missing mean or standard deviation or both of them in the normal distribution setting, you always have to use the Z standardization or the Z transformation to find your missing values. Okay, so you have to use Z score. Okay, so step 1 of this process will be finding your Z score. Okay, using mean value equals 0 and standard deviation value equals to 1. So means you don't always have to draw the graph like this in example number 1. We can straightforward use the inverse norm tab on your GDC. Okay, and you use the area from the question. Okay, and then for the mean you always use 0, standard deviation you always use 1. So this is something that you never changes. You always use the mean equals 0 or standard deviation equals to 1 for your Z score testing in this curriculum. And you find your Z value used by hitting enter on your GDC. Then you will find your Z score value, right? Then once you have your Z score value, you're going to step 2, you're going to use your algebraic expression. Z equals x minus mean over standard deviation. So that value here is the value that you got from the step 1. Okay, and your x, mean, and standard deviation depends on cases or depends on what are you looking for. You will be missing mean or standard deviation, or sometimes you will miss both of them. But your x, mean, and standard deviation values, it should be always original values from your question. Okay, and once you're done with the substitution, then you move to the step 3, which is solve for the unknown variable that you're looking for. Okay. Okay, then let's try another example. So here I have example number 2. The weights of an adult crab population are known to be normally distributed with a standard deviation of 5.9 gram. If the 15% of the crabs weighted less than 58.2 grams, then we need to find the mean weight of the populations. So we know that its normal distribution graph or its bell-shaped curve will look like this with the mean value that's unknown, but we know that the x value is 58.2 kilogram, and then the area below it is about 15% or the 0.15, right? Then to find this unknown mean value when the standard deviation value is given as 5.9, we have to use the z-score testing. So step 1, we need to find the z value, right? So we know that inverse norm, right? This is where you have to use the inverse norm. So we do area equals 0.15. Your mean value is 0, standard deviation is 1. Then you get your z-score value approximately equals to negative 1.036433. Okay? Then using this information from step 1, step 2, you have to use your algebraic expression, which is z equals x minus mean over standard deviation. So from the question, we know that also from the previous step, we know that that value is negative 1.036433. X value is 58.2 minus mean, because we are looking for the mean, and the standard deviation value is 5.9. Okay, then rearranging this equation will give us the mean value equals to 64.3. Then let's do example number 3. We need to find the mean and standard deviation of a normally distributed random variable x for which probability of x value less than or equal to 20 and the probability of x that is greater than or equal to 29, right? So in this case, we have to find both mean and standard deviation. So let's draw our normal distribution graph, okay? Then we have our bell-shaped curve. Okay, we know that p of x is less than 20. So if the mean is in the center, then we know that at one point here on the left hand side, we will have a 20, and the area below 20 is 0.1. Okay, and for the p of x that is greater than 29, we know that on the right hand side, at one point is going to be 29, and anything above 29 is 0.15. Okay, then using this information, we can actually calculate two different z values. Okay, so first one, using the inverse norm, okay, with the area equals to 0.1, mean value equals to 0, standard deviation equals to 1, we can say that that is approximately negative 1.282. Then for the right hand side, again using the inverse norm, we know that area is equals to 0.15, mean is equal to 0, standard deviation is 1. Then using GDC, we know that the z value is approximately 1.036, right? Then we can set the two equations using the algebraic expression z equals x minus mean over standard deviation, right? Then for the first one, we can say negative 1.282 is same as 20 minus mean over standard deviation. Then for the second one, we can say that 1.036 is same as 29 minus mean over standard deviation. Okay, then once you have two equations, you can set this equal to each other to find these unknown variables, which are the mean and standard deviation, right? Then for the first equation, we can set it up as 20 minus mean equals negative 1.282 times standard deviation. And for the second one, we can say 29 minus mean equals to 1.036 times standard deviation. Then this is same as mean equals to 1.282 times standard deviation plus 20. And for the second part, this is same as mean equals 29 minus 1.036 times standard deviation. Then we can set these two equal to each other, right? Then we have 1.282 times standard deviation plus 20 equals to 29 minus 1.036 standard deviation. Then this is same as 1.282 times standard deviation plus 1.036 standard deviation equals to 29 minus 20. And this can be simplified into 2.318 standard deviation equals to 9. Then we can say that standard deviation is approximately equal to 3.88. Okay. Then once you have this value, you can substitute this standard deviation value into one of the equations that we have set previously. So this is same as mean is same as 1.282 times 3.88 plus 20. So mean is about approximately 24.977. So we can say that the mean value of this case is about 25.0. So we have found that the standard deviation value is equals to 3.88 and then mean value is equal to 25.0. And that's how you calculate the mean and standard deviation when both of them are missing.